Hello, welcome to Math 1960, Section 301, Calculus 2, Summer Session 3. My name is Noon Tenny. We would discuss the first section, or the first lecture rather, of Math 1960. So the outline of this section, we want to discuss two topics today. So the two topics, first one is finding the area between graphs of two functions by partitioning x, and then finding the graph of two curves by partitioning y. Let's start. So first of all, let's consider the subinterval . Let's call this x of I minus 1 and then use of I and then this is x of I. So we want to partition the interval a and b. We want to partition it into x of 0, first subinterval, x of 1, and then second interval, x of 1 to x of 2, x of 2, or x of I minus 1 to x of I, x of n minus 1 to x of n. Let's assume that delta x, which is width of these subintervals, it's equals to v minus a divided by n, where here I is equals to 1, 2, 3, up to n. So, and then now let's say a of I is equals to, how do we find a of I? This area here is the subinterval x of I minus 1 and x of I. We want to find the area of this subinterval, and then we can generalize this into other subintervals. We said all these subintervals are equal in terms of width, but they're not equals in terms of length. So at this point, how do we determine the length, all right, of this rectangle? So here we're going to make a rectangle, and the length of the rectangle is being determined by midpoint approximation. So what we want to find is this area here. This area is not exactly the area of a of I, but it's an approximation of the area of a of I. A of I subinterval. How do you find the area of a rectangle. Area of rectangle is equal to width, which is delta x, times length. Length is being determined by f of ui minus g's of ui. So A is basically equals to summation from I equals to 1 all the way to n of delta x times f of ui minus g of ui. So A is equals to limit as n goes to infinity of summation from I equals to 1 all the way to n delta x times f of ui minus g of ui. Okay, so we know from our study that limit of Riemann sum it's equals to integral. So then the area A is basically equals to integral. So the integral start from A up to B, okay, of what function? Of function f of x, because u of I is nothing but x minus g of x delta x. So this is a formula that we will always use to find the areas between two curves when we are partitioning the x-axis. Okay, continuing in our lecture, we want to partition the y-axis. So to find the area between the graphs of two curves when we are partitioning the y-axis. Same method, we're going to take a subinterval and then we find the area of that subinterval and then we generalize or we generalize the method to find the area of the rest of subinterval. So first, let's select a subinterval and call it the first point here. Let's call this y of I, and the midpoint, let's call it v of I, and then another point here, we call it y of I minus 1. So first, so now in order to find the area under, or the area, this area here, between these two curves, we want to approximate this area by finding rectangles, right? This is like the method of Riemann sum, if you remember. So if we find this area here, which is an approximation of the area A of I, then we can generalize this method. So first, we're going to partition the interval. We're going to partition it. We will have C to D. This is the interval we have. We're going to partition it as follows. y sub 0, y sub 1, y sub 1, y sub 2, and then y sub I minus 1, y sub I. So here we're gonna have y sub n minus 1, y sub n. So now let's say the height of each and every subinterval is going to be constant, and we call it delta y. So delta y would be d minus c over n. And now if we want to find the area A sub I, it's going to be approximately equals to delta y times f of v sub I minus g sub v sub I. So A is approximately equals to summation from I equal to 1 up to n of delta y times f of v sub I minus g of v sub I. So now to find the exact A or the exact area, we need to take the limit. So every time we take the limit, as n goes to infinity, we would always find, or we would find the exact area, okay, of the area of the region. So here I equal to 1 all the way to n. So of delta y times f of v sub I minus g of v sub I. So when we take the limit of this, so the limit of the Riemann sum is equals to definite integral from c to d of f of y minus g of y dy.